All right, so combining with J.J. Thomson's previous experiment, determining the charge to mass ratio, Millikan's experiment was able to determine the charge of the particles. And they were able to do that once again from the Millikan experiment. This is the oil drop experiment. So we talked about this a little bit in our last unit or 2 units back, the electrostatics unit. But in this case here, we're looking at oil drops that are levitating. So if they can levitate or move at a constant velocity, that means for these oil drops, we have gravity pulling it down, but an electrostatic force pulling it up. And if these two are balanced, we could then make them equal to each other. So this is for something moving at a constant velocity or a levitating oil drop. So in this case here, an oil drop with a mass of 3.25 falls at a constant speed. If the electric field between the plate is 4 times 10 to the 3, what is the charge of the oil drop, and what is this measured in elementary charges? So in this case here, like mentioned before, we're going to have the force of gravity pulling it down, the electrostatic force pulling it up, and these are equal because it's falling at a constant rate, not accelerating. So mass times gravity is then equal to the electrostatic field multiplied by its charge. And it's asking for what the charge is, so we're just going to solve for Q. Q is then equal to mass times gravity divided by the electrostatic field. So in this case, 3.25 times 10 to the negative 16 kilograms. We're using it on Earth, so 9.81 meters per second squared. And then we're dividing this all by 4.00 times 10 to the 3 volts per meter or newtons per coulomb. And if I do this on my calculator here, 3.25 times 10 to the negative 16 multiplied by 9.81 divided by 4 times 10 to the 3, and I'm left with a charge of 7.97 times 10 to the negative 19 coulombs. If I want to figure out how many elementary charges this is, I need to remember that Q is equal to NE, where E is elementary charges, so N is the number of electrons, and it's roughly going to be equal to 5. So I got 4.98 electrons. So in this case, roughly 5 electrons. All right, so after knowing the charge to mass ratio using J.J. Thomson's model and now a charge of an electron, they were able to then determine both the charge and the mass, kind of combining this together, which is the first model. All right, so try these questions out. You have homework problems 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, all the way up to question 13, and there is solutions. So try those out.